Okay, let's dive into a story that stretches from the absolute edge of our own solar system all the way to the violent skies of a planet orbiting another star entirely. It's a tale of cosmic boundaries, ancient chaos, and the surprising resilience of life.
So it all starts with a puzzle that had astronomers scratching their heads for a long time. You see, we get these amazing visitors, long-period comets, that swing by the sun and then vanish for thousands of years. But where do they all come from? It's like there's some kind of endless comet factory out there.
To crack this case, we have to go back to 1950, to an astronomer named Jan Oort. He was looking at a really big contradiction, a paradox that just didn't make any sense, and solving it would force him to completely redraw the map of our cosmic neighborhood.
Here's the problem he was facing. On one hand, comets are basically big, dirty snowballs. Every time they get close to the sun, a chunk of them boils away, so they shouldn't last very long. Logically, they all should have fizzled out billions of years ago, but they haven't. New ones just keep showing up all the time from every direction. So what gives?
Oort's solution to this was frankly mind-blowing. He suggested there had to be a gigantic, invisible reservoir of comets way, way out past the planets, a structure so enormous that it completely changes what we think of as the edge of our solar system.
To really get a feel for the scale he was talking about, let's take a quick trip. We'll start right here. The distance between the Earth and the Sun is our measuring stick. We call it 1 astronomical unit, or AU. Pretty simple.
Okay, so we head out. We fly past Mars, Jupiter, Saturn, all the way out to Neptune and the Kuiper Belt, where Pluto hangs out. That's about 50 AU. You'd think, okay, this has got to be the end of the line, right? Nope, we're not even remotely close.
Now, to get to just the beginning of Oort's comet cloud, you have to take a truly massive leap into the void, all the way out to 2,000 AU. That's 40 times farther out than Pluto is. We are way out in the dark now.
And it just keeps going. The outer edge of this thing could stretch to a staggering 200,000 AU. Let me put that in perspective for you. That's more than 3 light years. The true edge of our solar system's gravitational pull is almost halfway to the next star. That's incredible.
And this is it, the Oort cloud. It's this theoretical but almost certainly real sphere made of trillions of icy leftovers from when the planets were born. It's so far away the sun is just another bright star. And every so often, the gravity of a passing star gives one of these ice balls a tiny nudge and sends it on a million-year journey towards us. And just like that, Oort solved the paradox.
Okay, so that answers one question, but it brings up a new one, right? How did trillions of comets get way out there? Well, they weren't born out there in the cold. They were kicked out of the house, violently, from right here in the inner solar system.
You have to picture the early solar system as this chaotic cosmic pinball machine. You had all these icy objects forming near the giant planets, but the incredible gravity of young Jupiter and Saturn acted like a giant slingshot. They would just grab these things and fling them into the darkness, creating this massive, distant cloud of exiles.
So the violence that built our solar system is mostly in the past. But that gets you thinking, what if you lived on a planet where that kind of chaos was happening right now? Could life possibly survive? And that question takes us to the most common and, frankly, most cranky type of star in our galaxy, the red dwarf.
Our sun is pretty calm and stable, you know? But M dwarfs have a temper. And because they're so dim, a planet needs to orbit super close to stay warm enough for liquid water. But here's the catch. That close orbit puts the planet right in the firing line for the star's frequent and incredibly powerful stellar flares.
So what would that actually be like? Well, a team of scientists decided to find out. They built a virtual Earth-like planet in their computer and put it in orbit around a real, very active M dwarf. And then they blasted that planet with a simulated superflare to see what would happen.
And the result was devastating. The flare slams into the atmosphere and just annihilates the planet's protective ozone layer. The simulation showed that 94% of it was just gone. For anything living on the surface, it would be like having your planet-wide sunscreen instantly vaporized.
So that's it, right? Case closed. No life can survive that. It seems like a total deal breaker. But when the scientists looked really closely at what was happening, they found something really surprising and maybe even a little hopeful.
Yeah, you heard that right. Even after seeing the atmosphere get shredded, the scientists concluded that these giant flares might not be a death sentence for life, which sounds completely insane. How could that possibly be true?
Well, it all comes down to timing. You see, while the ozone layer stays damaged for a long time, the absolute worst, most life-frying blast of UV radiation that actually hits the ground is over in a flash. It lasts for less than 2 minutes. The deadliest part of the storm is incredibly short.
So, when you put it all together, our journey shows us something amazing. The universe is a violent place. The chaos that shaped our own history is a daily reality for worlds out there. But the big takeaway here is that life might just be a whole lot tougher and more resilient than we ever gave it credit for.
And that leaves us with this incredible question. If life could survive a blast like that, maybe just by ducking underwater for a couple of minutes, what other impossible places have we written off too soon? It makes you wonder. Maybe the universe is full of life hiding in places we never thought to look, just stubbornly finding a way to hang on.